So this is the course, Software Development for Technical Applications. I would have hoped to have this course on site this year, but situation is not that good yet. So what is it about on a high level? So this course is about how to implement the finite element code from start to finish, and that includes developing the numerical model, providing the model in a way that you can reuse it, create a user interface, and also visualize input and the results. So kind of to create a complete usable project. So the user shouldn't have to understand too deep what the actual finite element model is, the theory on that, but can use the program as an engineering tool. So that's the high-level idea of this course. So these are some examples of things that applications that are developed in this course. So that's what you can expect from when you're done with this course. There's also now I'm showing only temperature and the groundwater flow, but there is also one material example that you can also use implement. Lectures will be Mondays and Wednesdays on Zoom. Please check the calendars because there are some changes, but the calendars in Canvas should be correct. And also the schedule from Schema Generator should also be okay. So there will be, I think, 7 lectures. And today we are going to start with Introduction to Python and the development environments we're going to use. Next lecture will be on matrix computing with Python. There will be a lecture on the CalFem toolbox for Python. So basically, this is the toolbox that similar to the one you probably have been using in the finite element courses for MATLAB. So this is a CalFem for Python. There will be a lecture on user interfaces and object orientation, scientific visualization and Python. So how do you do your visualize your results in Python? There will be a lecture on perspectives on Python, so how you can use Python in different ways, in different applications, and also in your profession later on. And hopefully you have also have a nice guest lecture from a company that actually implements some of these methods in commercial products and offer their view on how they develop their software and the future of finite element applications going forward. So there will be exercises as well on Zoom on Tuesdays and Thursdays. I think I check the calendars because there are some reorderings now with Easter here. So check the calendar. During the exercise, there will also be breakout rooms, so you can always ask for help. And me and Karin will probably jump into the breakout room and help you individually. The course is laid out with you implement one worksheet per week, basically, except for the first week, which is a general Python worksheet. But the project will be divided up in 5 worksheets, and when those are done, you write your final report. You can work individually or in groups of 3. The examination is based on you have approved assignments, approved final report, and a participation in the final seminar. So you can already, it's only a pass or fail grade in this course. And the final tentamen is the project presentation at the final seminar. So hopefully you should have been able to go into Canvas. I think I saw that most of you have been able to log in. So this is the address here, 11184. So that should be the Canvas homepage for this course. All material will be available through this site. Also, you also turn in your assignment through the Canvas page. Literature. So for those that are fluent in Swedish, there is a book called Ingenjörens Guide to Python in Swedish, which covers a lot of the topics I give in this course. There is also online documentation on Python inside, which I reference in the Canvas site. There is Learning Python, Programming Python. The worksheets are also part of the course. And finally, you will also get a lot of example source code that you can look at yourself. So there will be a lot of examples. You will have access to most of my material for this course is available on GitHub, where you can download and use to run your examples and try it out. We were using Python, and preferably you should install the Python distribution that comes with Anaconda. It's a commercial Python distribution, but it's free for academic use. And it contains most of the packages you will require for this course. There are, however, some packages that needs to be installed separately, and that is the mesh generator GMSH, really strange name. And that will be installed in part with Anaconda. Calfin for Python is also installed separately, but also with Anaconda. So the instructions will be available in the course homepage Canvas. So now it's both Swedish and English here. But so we will develop one finite element program, which will be implemented in Python. And you will select one of these problems. So you don't have to implement 3 different problems. So you can either choose plane stress, 2-dimensional heat conduction, or 2-dimensional groundwater flow. So you can select one of those examples and implement them. And that is the program you will kind of use, the problem area you will use for all the worksheets. So you don't have to implement all of them, just one of them. So select what you feel is kind of closest to your area of study, and then go with that. Yeah. So as I said, it's developed in several stages. Each stage is an assignment. So just to kind of give you a high-level view of the things that we will develop in this course. So the numbers here are the assignments. So in the first assignments here, we will first go through, learn some of the Python things, but then we will focus on developing the finite element model for your problem area. In the next step, we will be implementing defining the geometry based on it will be a parametric problem, so you will give the size of your problem will be given in certain measurements, height, width, depth, and so on. And from that, you define a geometry. And then next, you will, with help of CalFem, you will generate the mesh and then do the visualization. So the first part will be focused on actually getting something that solves your problem, and that's your visualization. And then in the last 2 steps, we will develop a user interface so the user can enter data into your developed finite element model and create an easy-to-use application that you can use without any deeper finite element knowledge. We also have, so this is a high-level model of the program that we will develop. So we will use the CalFem package here. This will be used by our solver, which is one part of this problem. We will have a plate model which describes our problem area associated with loads and material. And then we have a user interface here that will be a plate window. It will use a Qt user interface library. Our model will also use the matplotlib library for plotting, WizViz for some of the parts. So this is kind of a high-level model of the final program. And Colford would use this GMSH for the actual mesh generation part. So this rectangle here is the finite element code without any user interfaces. This is the user interface, and these are the dependencies that the toolkits that we're using to kind of solve our problems. So the worksheets are all available. I haven't restricted any access, so you can work, continue to the next worksheet if you want to do that. I will show how these are. So you can see here, this is the web page here is VSMN20 read-the-docs.io. Here you have all the worksheets available here for the course. There are one English version and one Swedish version, so you can select the one you want. And the first worksheets is basically just a refresher course in Python. And then we have worksheet 2, which is actually the start of the finite element code implementation. That is also available in English. So here you can also say in the end here, there are several examples here of different element types that you can use in the code. An example that you should implement in the first step. But all the worksheets are available, so you can, if you want to continue working with this course and continue on. I will also add, for those that want to do more advanced stuff or develop the examples further on, I will provide some worksheets that are kind of optional that you can add if you want to add more functionality. So this question I get many times every time I have the course, but I want to do it my way. And that is perfectly okay as long as you complete the tasks in the worksheets. So the functionality of each worksheet must be available in your own code. But you don't have to do it exactly like a worksheet. You can implement it in any way you want, as long as it kind of solves the problem. And I also, as I said before, I will provide extra worksheets for those that want to expand the project assignment. So you need to solve the basic task. Graphical user interface. The user has to be able to enter the input for the tasks. You need to implement the computational model, of course. You have to visualize, and you still have to submit every week what you have done. So, but it's open in that sense that you can, if you feel that you are good in programming and you want to kind of, I know this stuff and I want to do it this way, it's okay. So, just before I go into the actual, I want to give you an overview what this course can provide you the tools to implement, or what you can do with this. So these are not necessarily Python examples here, but these are some of the things that have been done at structural mechanics using the same technologies that you will get from this course. So, for example, sometimes you have a problem that you can't solve with the normal tools that you have. For example, there is no preprocessor for adaptive control on a very large telescope, for example. So we implemented a visualization tool here in C++ for visualizing this. This is also a tool that started as a master thesis work a couple of years ago called Sketcher-Frame, which is an interactive tool for studying the behavior of trusses and frames. And it's in real time, so if you move things around, it will update in real time the model. ForcePad, perhaps you have seen this application. It's used some in teaching structural mechanics. It's also finite element code for use by non-engineers and engineers. So it's an interactive tool for quickly visualizing stresses in different structures. Hakon is a finite element code that has been developed at the Abstract Mechanics. It was commercial before, now it's free to download. It simulates the process of hardening concrete. So when you pour concrete, energy is developed, and you need to kind of have control over the process. And this program can simulate the hardening process. Here's another example of programming of this finite element code programming. Is we implemented a truss or a frame program that could interact with a leap motion, which is a hand controller that can so you can basically pinch and move things in the model by using your hand. It's another example of visualization of fiber networks, where we had the problems at the time that the computer hardware couldn't visualize a lot of fibers or a lot of surfaces. So we simulated rounded tubes by using textures. So all these textures here they are not actually rounded tube, but images that are attached to flat fibers that are directed to the camera. So that was that part. I want to show the development environment that we are going to use. So in Anaconda, there is a development environment called Spyder, which is very similar to the MATLAB environment, the MATLAB editor. So in this, you can edit Python, you can debug running Python code, you can inspect variable values. There is a built-in documentation browser. There is an interactive Python prompt you can use, and you can also use plotting directly inside this environment. It's looks like this. On the left side, you have the, let's see here. So on this side here, you have the text editor. On top here, you have the help view. And you also have here, you have the current directory which you are where you are working. You have the Python console here where you can execute Python commands interactively. You can create files using file new, file save, file open. I will show you that later here. So when you create new, it will create an empty file and with some input in it already. So just to kind of explain before we go in too deep in Python. So the first line here, the bracket here is a comment in Python. These kind of strange things here is a special encoding that tells the Python interpreter that there will be foreign characters in this text. If you don't do that, it will use plain standard English ASCII, and it doesn't know how to interpret the Swedish characters, for example. So using this UTF-8, you will be able to enter Swedish character in your source code. The next 4 lines here are comments as well. So these 3 quotes here are something called a triple quoted string in Python. And that is also something you can use as comments here. And this is just that this can be removed, but it's always nice to have a stamp when you created the files and who wrote the files. So I will try to run it interactively instead of doing the PowerPoint here. I'll probably got an old Spyder here. Okay. I think when you install this, the version will be 4. Oh, this is my laptop computer, so it's a different version here. So let's see here. So this is the situation when you start a new program here. It will create a file called Untitled Py, and if you press Control Save, it will directly ask you for the file name. So I just press test.py. that. And now I can do and then if you want to run your Python code, you can press the play button here on top. And you will see here it will start the code here in the console window. And you see the output here from the code. You can also see the variable explorer here, which shows you the active variables in the running interpreter. So in this case, the only variable here is I. It's an integer variable, and it has the current value of 9, which should be correct here. Here you can also, in this interactive window, you can look at the variables here. You can create other variables. You can execute interactive command just like a MATLAB window. So that's there is also some other commands that is good to know in Spyder. So let's see here if we can go back to the presentation. So running a Python script, as I said before, is you press the play button and it runs. And it runs in the active Python interpreter in the lower right window. You can also list, like in MATLAB, you can list the active variables in your session. So in your active session, you can do who. Let's see here. So you can enter. Oh, that was big. It's a bit too big. So who is here? That is the command to get the variables that in your current session. You can also, if the code is going into a loop or something, it doesn't stop, you can press the red stop button here, and it will stop the current executing command. As I said, there is a variable explorer that you can see the active variable. It will kind of visualize lists and matrices as well, and visualize them in a way that you can read them quite good. So it's a nice tool. Very similar to the one you have in your MATLAB environment as well. There is also a tool you can press the right button on the variable explorer, and you can plot the data directly. So it's one nice way of kind of examining your code if it's working correctly or doing similar stuff. So there are some other, you can do histograms as well. Yeah, so interactive Python. It's a special version of the Python interpreter that has been enhanced with several commands that are not available in normal Python command, but more for interactive use. So here's some example of a session here. You can type a variable, work with it, print it. In the IPython, you can also get help by using the question mark command. You get the Python. You can also always put a question mark on any variable, and that brings up more information on the object that you're inspecting. So if you do object with 2 exclamation, you get even more information. So for example, here you have a question mark, then it says that this is a type string, and it contains hello IPython. It has the length 15, and it also provides a documentation string. So for example, all objects in Python has built-in documentation, so you can always print this documentation out using the help command as well. And there are something called the magical functions. Those are prefixed with a percent operator, and those cover interaction with the system, convenience function, timing, and execution. So these are functions that you will not use in your Python code, but when you're debugging your code or you're experimenting with something in Python, you can use these magical commands. So for example, you can use the %cd command to kind of switch directories. So in this case, I cd to documents, and then it goes into the documents folder of my computer. You can print the working directory. So just ask the computer, where am I? And it will print out the current directory where I'm working. You can do #ls, which stands for list files. It will list the current directory of your computer. You can also print the contents of files that you have in your working directory. That can be used when you're coding and creating files. You want to display them and see if they are containing the correct information. Then you can do pycat and then the file name, and it will display the file name in the interactive prompt. You can also run a Python script it would be run from the command line or as a program, and then you use the run command. So you said run and then the name of your Python file without the extension. So in this case, run format1. It runs a file called format.py that is on your hardware. So Python source code files always have the extension .py. That is a standard convention. So if you run, it will search for a format1.py file, which it will run. There is also an option called run -t, which actually times the run. So if you have for example, a finite element code, you want to see how fast it runs, you can use the t to see, oh, it spent the wall time here. That is a total time of execution. It's 0.01 seconds. It's divided in user time and system time. So user time is time spent in your own code. System time is time spent in the operating system code. So you can see if your code is kind of, if it's writing a lot to disk, it will probably be spending more time in system than in user. But wall time is the total time of your program. There's also a function called timeIt, which is more precise, which can time a function, for example, how long it will take in very high resolution, nanoseconds here, for example. Whos I showed before, list the variables that are available. Some of these commands are available without the % as well. So sometimes they're clash with the Python environment, and then you have to use the %. For example, whos you can write directly in the prompt without the %. There's also an exclamation mark command that will run a system command, for example. So if you're on Windows and you type exclamation mark dir, it will execute the dir command, which will list the files in your current directory. But it will do that by actually executing the dir command in Windows. You can do the same thing on a Linux or Mac machine. You do exclamation mark ls, and it will execute the ls command of the system, the built-in system for listing files, instead of the built-in one in Python. So that was that. So let's see here. I will show you also I will all my lectures I will give are provided as something called a Python notebook, which are a combination of code and text in a single document, and also graphics. And the nice thing with that is that you can actually follow along the lecture and try out examples yourself. I'm also trying something new this year, is that I will give you some you can actually do some assignments in the lecture as well, just to kind of try it out yourself. So I will break at some points to let you try it yourself. But you can create your own notebooks if you have a Google account. There is a built-in service for running Python code in Google. So in this case, I'm in my Drive here. I'm logged into my normal account here, and when I press New here, I go down to More, and I go to Google Colaboratory. So this is the Python notebook service that are built into Google. So if I press this one here, it will create a new notebook for me. So in this case, you see here, I have a prompt. I have some menus here available. There is something called Anslut here. I'm sorry for the Swedish. I don't know. I think they notice I'm Swedish here. Anslut or connect. That will start a Python interpreter in the background, so it will handle your. So this is the first thing I usually do. I press this. This will actually allocate the server somewhere on the web, running the notebook and also the Python interpreter. So here I can do a equals to 42. I can do print a. Then I can press Shift Enter here, or press the play button here to execute the code. Now you see an output is shown here. What you can do with this is you can combine text and code. So in this case here, I can do add a text here, and I can press here press Shift Enter here, and it will interpret this as a formatted text here. I can change it to 43, and I can press play again here, and it will execute the code. So it's a very nice thing if you want to do something more structured. You want to have basically like a report that calculates things. You can both write the explanation what you're doing, execute the code, get the diagrams out. So it's really a nice tool that is available for free in Google. So coming back to the course here, this is the Canvas page. Make it a bit bigger here. Here you find all the information about the course. Here is a module here with software packages, what you need to install. You have the web-based course material. You have the literature here. And all the lectures are provided here in modules. And I will also add a video lecture at the end of this lecture here. This will be provided here that you can look at the lecture afterwards. And the lectures here will be mostly as Python notebooks. So in this case here, I press the introduction to Python here, open a new window. And hopefully it will show my lecture here, otherwise it will be not so much fun today. So here is my lecture. On the right here, you have the contents here, the outline of the basic Python lecture here. And this is the lecture material. I already have a machine allocated here. So let's start with the lecture then. So this will be an introduction to Python. So we're trying to give an overview of what Python is and the peculiarity of this language. So Python was created. Oh, I have a question here. Can you use Colfem in the Google Colab? Yes, you can. So I have many examples that you can run directly into in Colab, but you need to download and install Colfem before that. I will show you some links to that later on. So Python was created by Guido van Rossum in 1991, and the goal for him was to create a language that supported code readability from the beginning. So the readability was supposed to be inside a language from the beginning, so that even if you wrote large application, it would be kind of impossible to create very unreadable code or complex code. So the actual code should be able to read it easily. It's dynamically typed. I will go into that in more details, but basically there is no explicit type declarations like you have in C, Fortran, Pascal. But it's very strictly typed in that sense that when you assign a variable an integer, it is an integer variable. So, but you can easily switch a variable during the lifetime of your code. The variable can switch data type. So that is something can be quite hard to learn in the beginning, but it's very flexible. It gives you very much flexibility. It also supports multiple programming paradigms. So you can program structured and procedural code without even touching anything of the object-oriented parts. You can also do functional programming that is very modern today. So you have all these things, and you can choose whatever style you want yourself. So there are some language versions here. So the version 2 of Python was released in 2000, Python 3 in 2008. And with the 3.0, there was a lot of, they broke a lot of backwards compatibility by design. They wanted to kind of break free from some of the concepts that were introduced in Python that was not very good. So they tried to change those in 3.0. The latest version of the 2 series is 2.718. It could be that this is actually, there will be some versions more, but they will not support 2.7 anymore. That is, this should have reached end of life last year, but it didn't. But it's not actively developed anymore. The latest version, I think now has been updated, so it's 3.9. And we will be using 3.7 or 3.8 in this course. So the philosophy of this of the language is beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. And complex is better than complicated. So readability counts. That is one of the important things with Python. You can read a lot more of the history of Python on the Wikipedia page here, but it's interesting language philosophy. Python is it's not a compiled language, so it executes code line by line, and those lines are stored in text files, and those are translated into commands that are understood by the Python interpreters. Empty lines are ignored. Text file, all the source code files that are executed in Python usually have the extension py. So it's a very simple structure. So basically, you just create a new text file. You can have some parts here that are specific to your environment here. So in this case, the first line here is actually not interpreted by Python, but by the system to where it's what kind of Python compiler should it use to execute this command. This is the coding of the file. This is a comment, and then you have a for loop here as well. And then the one thing that is a bit interesting here is that there is no curly brackets or begin or end. So the structure of the program is actually defined by the indentation. So this is a for loop here. We'll go into for loops later here. And this print statement here is part of the code block for the for statement. So because it's indented here and there is a colon here, that defines the code block associated with a for loop. So indentation has a meaning in Python. It's very important that you set your editor to the correct number indentation for tabbing, preferable using spaces, and have consistent indentation in your source code files. Functions are defined by a function name, parentheses, and then a list of parameters. And most of the functionality of Python is provided by its runtime library, which is extensive and very large. The print statement here, for example, here you have a string parameter here, and then you have an integer parameter, and the print statement will take this parameter and print them out on the screen. You can also skip parameters if the function allows that. Then you have to still specify the parentheses and give any empty parameters without any parameters. And then you have functions that have return values. So a function can have return nothing, or it can return something. So everything in Python is function, and if it doesn't return, it will return a value of none. So here is an absolute as is a math function built in, and it will the y variable will be assigned this value here. Something also that is new is you can return multiple values from a function. So you can have q and r, and so dipmod here it actually returns both quotient and the rest of the result of the function here. So this is something special. I think you can do this in MATLAB as well, have multiple return values. I think we take 10, we continue again, say 13 after 3, then we don't stop in the middle here. So we do 15-minute breaks from now, and I continue again 10, 13, 15, 13 or something like that. Okay? Okay, so let's continue. So before we dive too deep into data types, I want to mention something about how variables are handled in Python. As I said before, Python, you don't need to specify the data type when assigning variables. And the data type of the actual variable is determined by the data type itself during the assignments. And also a variable reference can refer to different data types during program execution, which is also something, it's a feature of Python, but can also cause some confusion if it changes and a function is called with the same variable with a different data type. So in this example here I assign 2 variables here with 1 and 15. So 1 and 15 are integers. That means that A and B will be integer variable. So the data type will be integer. C and D here, you give us floating point value here, then the data type will be floating point. If you assign a string, it will be a string data type. If you assign a list like this, it will be a list. And then you can assign A again using a string, and then A is a string data type. So this is perfectly legal. Let's see here if I can run this code here. That's perfectly legal, and A now is a string. So if I do here, run it again, you see here it's a string, and it was an integer from the beginning. So this is something that is not possible in very strong typed languages, that you can switch data type of a variable during execution. Variables can be named in different ways. So you're only allowed to use letters from the English alphabet in your variables. You can use numbers. Also, you're not allowed to use special character except for the underscore character. And a variable can't start with a number. So allowed variable names are first name, which starts with a character. It has an underscore, which is okay. Last name, same thing. Number, I2, it says a number and starting with a letter. These are not allowed here. So one var, it starts with a number. L is also not okay because it starts with an international character. Another thing that is important to know about Python variables, that all variables in Python are references. So when you assign a value to a variable, the following happens. So the first thing is that you allocate memory for the value that you want to store in the variable. Then you create a named variable reference to the variable itself, the A, for example. And then this variable refers to the memory for the value, the memory allocated for the value of the variable. So if you look at the following code here, A equals to 42 and B equals to 84. In memory, this looks something like this. So A here is the variable itself. 42 is the memory location in memory of your computer, and A points to 42. So if you B assigned 84, and B points to 84 in memory. So two different memory locations. So something that is a bit different from other languages, for example, if you do A equals to B, and we run this here, you see here now both of these points to 84. So what happens here, in other languages, A will be assigned the value of B, but in Python, A will be assigned the reference of B. So in memory, it looks something like this. A now points to the same memory location as 84, the same memory location as B. So this is something that is, you have to kind of, you don't have to think too much about it, but it's good to know that this, everything is a reference. So if I assign A equals to 21 again, then it's the same thing here. 21 is created. The memory for the 21 number is allocated in memory, and A now points to this memory location. So now in this case, you have A points to 21, the value 21 in memory. And now you have a memory location 42 that has no reference, and then that is memory is freed by Python automatically. So if you don't have any variables pointing to data, that data will be removed. You can check the actual the storage location of a variable using the ID function, and here you can see that what actually happens behind the scenes without my figures here. So first we have A and B equals to 42 and 84, and then I print A and ID A. Then I get the actual memory location of A and also B. I do the A equals to B, and then we print again the ID of these, and then we do A to 21 and print out the memory location here as well. So if you look here on the output here, the two first one here, those are two memory locations, 32 and 76. Then we do A equals to B, and you see here that both of them refer to the same memory location. Then we assign a new value to A, and you see here that now A has the reference of 60 here at the end, but B still points to 76. So this 32 memory reference here kind of disappears from view, and it's not referenced anymore, and it will be deallocated or removed or cleaned up by Python automatically. So I want to show you, it could be kind of a bit complex to understand, but it's good to know that a variable is a reference to data in memory. So it's like a garderobsbiljet or a ticket when you go to put your clothes at a restaurant. You get the ticket back, and the variable is the ticket to my jacket. So it has a number, it points to where it's located. So data types in Python. I said before, we have integers, we have floating point values, and you can also operate on those using operators and expressions. So normal rules apply here. 2 plus 2 is 2. You also have the precedence of multiplication division has a higher priority than the minus and plus. Something that is a bit you have to be careful if you are using Python 2, which you probably won't do, hopefully. Integer divisions are interpreted as integers. And in Python 3, integer divisions will be converted to floating point. So this here will be 2.333. In old Python, it will be rounded, and the result will be an integer as well. But so this is a behavior that changed from 2 to 3 or Python. Let's see before here. You can have Boolean variables that are either true or false. and you assign them using the special keyword true with an uppercase T, and or false with an uppercase F. Lists. One of the most used features in Python is the ability to create lists very easily. And it's really powerful feature, and I think you will use this multiple times if you're starting programming in Python in any way. Lists are very flexible. To create a list is very simple. You assign a variable an empty square bracket like this. This will assign values to be an empty list. You can also create list pre-filled with values. Then you just have a bracket here, and then you list the values that you want to contain in the list separated with comma signs. And a very nice feature of lists is that they can contain any value data type. So a list can have integers, floating points, other lists, strings, other data types. So it is a generic data collection that is very powerful. You can access the items in a list by using the bracket. So in this case, I just have to run this. So So if I want to access, for example, the third item in the list, I can specify the index in a bracket here. And also note that all lists in Python are zero-based, so they always start at index 0. I have a question about a list and a vector, the same thing. So it's always a question of interpretation. You can always create a vector that is a list, but if you look at what we're going to do in this course, I would say that list is a generic collection of data types. In the coming lectures, we will be talking about matrices, and there is distinction with the arrays and matrices that can only store numbers. So a vector is not the same thing as a list, in my interpretation. But you can, of course, have a vector with 3 components, floating point, that is a list. That's possible as well. And I also can say that it can be tempting to start using lists as matrices for computation, which is not very recommended because the list in itself has a lot of overhead for handling different data types. And if you want to work on numbers, you should better use the NumPy arrays that we'll be using or I will be presenting in the next lecture. And NumPy is optimized for handling arrays and vectors of floating point values. Yes. You can assign values to specific indexes using same notation here. So you give square brackets here. So in this case, it's position number 5, and I assign a string to that position. And let's see what happens. So I'm going to say 0, 1, 2, 3, 4. So this is position number 5, but this start with 0, 1, 2, 3, 4. So I think that MATLAB is 1-based. So that is also, the Fortran language is also default 1-based. So if you're combining Fortran and Python, you have to think about the indexing. Another nice thing with lists is that you can wrap around lists by using negative indexes. So if you, for example, do print values -1 here, like this, it actually accesses the last number of the list. So imagine that you can go from the left side of the list. If you do -1, you go back to the right side of the list. So it kind of is cyclic. So if you run this here, you see you get 1.0, which is this position here. So -1 is a very useful feature if you want to access the last element of a list. You can also have higher indexes with negative indexes, and then it kind of wraps around and continues backwards from the list. So in this case, it's from -1, -2, -3. So that is the fourth value here. Something that also is important to understand about lists is that the list itself also contains references to data in memory. So if you look at the list here, this list, for example, here, in memory, it looks like this. You have 1, 3, 6, 4, hey, and 1.0. These are memory locations in memory. And every item in the list is a reference to this memory location. And here, where it can be somewhat confusing. So in this case here, I create a list, and I do b equals to values 4. So b is equals to the fourth value is 0, 1, 2, 3, 4. So in this case, b will have a reference to the memory location of hey. If I run this example here and I print the ID of b and I print the values of ID of 4 here as well, they actually refer to the same address now. So b points to the same memory location that the hey in the list points, the list item 4 points to. So this is something that often makes a lot of problems in code. So if you look at the visual image of this again, you have the values here points to list. The list has a lot of references here, and hey, the fourth position points to this one, and b also points to this one. So what can happen is that if you change, for example, b, or if you change the list value of 4, so values 4 equals to I'm not going to do the stupid example here. Just have to be aware of it. So this is how it looks in memory. So there will not be any assignments in this case. So b will still be the same memory location. As I said, in most cases you don't have to think about this. It's kind of the standard. It works like you think it would work. You can also do index notation and lists, so you can specify ranges of lists, and that you do using the colon notation here. So you have a 1:3. That means that it will start with 1 and go up, but not including 3. This is a bit odd syntax, I know, but it's the way it has been in Python for always. So this will print 1, 2, 2. You can also do starting position 1, going to the end of the list. So here you can use the minus notation again to reference other stuff here. You can also omit the end index here, and then it will start on position 3 and go to the end of the list. If you just specify a colon, it will reference all items in the list. -2, it goes to the next last element, and so on. So if you just run this and see what happens. You can see here, so you get different ranges of the list. You can query the size of a list, and that you can do using one of the more generic functions in Python. So there is a function called len, and that is used for all data types in Python, that collections and stuff, to query the number of items in the data structure. So to get the number of items in our values list, we just do len values. Then I get 7 here. We'll come to dictionaries later on, and dictionaries also have this, can also contain values, and you can also use len on dictionary to retrieve the number of values in the data structure. You can add values to lists, and now we get into a bit of the parts that cover object orientation. So Python is an object-oriented language. All the variables you're using are objects in some form, and they have a lot of methods or functions you can call on them to do stuff. So you can tell an object, for example, add something to yourself, and that is what we're going to use here. So we have the values variable here. It's an object, a list object, and the list object has a method you can call called append, which takes input the value you want to add to this list. So running this will add 42 at the end here. There is also a method called insert, where you can insert data into the list at a specific point. So this will insert squeeze here before 1. So it should, I think it will go after 1 here. Let's see what happens. So it will, after the index 1, it will add this item to the list. You can remove items from the list. So in this case here, you have the remove method. And then you can actually remove a named value. So if you want to kind of see remove squeeze, this string, it will remove the first value with which contains squeeze. So let's see here if we have run this. Squeeze is there before remove, after remove it's gone. It's also possible to use the del function. This here you do del and then you specify what to remove. In this case, the index 0 of values. So that also seems to work. You can also use ranges with delete. So in this case, I want to delete everything from 3 and to the end. And you see here, now all that's left of this is 3, 6, and 4. There is also a method called pop, which can implement the stack data type in other languages. So stack data type is something where you push item to the stack and you can pop from the end again. So if you do, and that value, that will return a value from and remove it from the list. So in this case, let's see what happens. 3, 6, 4, and we pop, and then we pop at the end. So in this case, the 4 will removed, and V now will assign that value 4. Clearing lists can be done using the clear method. So if we have a list A here, you can also assign an empty list to that variable. So the difference is that you could have in Python have multiple variables referring to the same list, and if you assign the second variable an empty list, the list is still available from the reference of the other variable, and then in that case you can use the clear items instead. So in this case, the next example here, I have an A list again, and I say B equals to A. That means B now has a reference to this list here. So both A and B points to the same list. If I do A equals to empty list and I print B, let's see what happens. Oh, the list is still there. So even if I empty the A list with an empty bracket, the list is still there. So if that is not what I want, I can use the clear method instead. So in this example here, I have A equals to this one, B equals to A. So I do the same operation. Both A and B points to the same list. And then I do A.clear. And now you see that B is also empty. So clear kind of works on the items in the list. And assigning an empty list creates a new list that you assign to a variable. The old list could still be there if there is a reference to that list by another variable. You can have nested lists, so a list can store other lists. And this is one of the more cool features, I think. It's very easy to create complex nested structures just using the list data type. So in this case here, I have A, and I have 1, 2, which are normal values in the list. And then I have a list here, 3, 4, which is the third item in the list. 5 and 6 are integer numbers in A list. And I can reference the list again here by printing at A2, and that will return me a list as well. So in this case, I get the list that is stored at position 2. So 0, 1, 2, this is a list, and I get out this one. You can, if you want to reference an item in a specific nested list, you can just add index operator to the variable. So in this case here, I have a nested list here, and I can do A2 and then bracket 0 here. That will go into the list at item 2, and then the 0 element of this list. So this should return a 3 in the first one and a 4 in the second one. Yes. So this is where you can implement two-dimensional lists, and then you can reference them row by column, for example. One example here could be, for example, to create a spreadsheet with data inside it. So I have a spreadsheet with rows and columns. I create a spreadsheet here with an empty list, and then I add lists of rows. And now I can use a very neat trick here. The multiplication operator in Python can be used to multiply elements and create a larger list. So in this case here, I have a list consisting of one single element. When I multiply that by 10, it will create a list of 10 elements. So it's a quick and dirty solution to create data structure quickly. So now you see here, it appends 4 rows with 10 columns in each. And then I print it out, and then I can lend the spreadsheet. It should return the number of rows. Then I can access every element in the spreadsheet using the rows and column notation. So you see here the list contains 1 row here, 2nd row, 3rd row, 4th row. And then you see here it has the length of the spreadsheet is 4 because it has the outer list has 4 elements. And then you can see spreadsheet row number 0, item 5. Everything is 0 here, so it's obvious it should be 0 here, but you access them using these double brackets. Quite nice. Yeah, as I said before, this here, when you're using nested list here, you have to be aware of I have a list here B, I add that to list A, here in this case. If I do B 0 equals to -1, so I change the first element of this list. This will change the B here, but it also will change the A here. You see here that -1 here, -1 there. And if this is not what you want, if you want to add a list, the items, the list here as an own entity inside here, you have to do something about it if this is not what you want. So what happens here in the above example is that you have B points to this list, A has these references here for 1, 2, 5, 6, but also reference to this list here. So if you modify this one, the data in A will also be modified because it points to the same memory location in the computer memory. You can solve this by using the copy method. So copy method will create a copy of the list, and you add a copy instead of the actual reference to the list. So in this case, you will have another memory location created with the same data here. So the memory location will look something like this. So this is the old list which I changed, and this is a copy of the first list here, the 3, 4. And if I change B, this will not be changed. You can see it's here. I changed B with -1 here, but the A list still has 3 and 4 inside. Another important data type is strings. So strings in Python, they store sequences of letters. And if there's one thing in Python that you can do in many ways, it's creating strings. There are so many ways of creating strings. There are so many different string types. And that is because of the strings can contain international character. They can have different character sets, and you want to store templates with character returns. So there is a lot of needs for flexible string creation. There is one thing that is kind of strange, and it is that when you have created the string is mutable. You can never change a string in Python when it has been created. It sounds like a hard limitation, but it's actually not very hard limitation because it's so easy to create strings in Python. You can create a new string that has a substring of another string. and then you just throw away the old string. So it's not a hard limitation. So you create string by creating a variable name and assigning it a quoted string like this. And you can have double quotes as string delimiters. You can have single quotes as string delimiters. It's equivalent, so there is no difference. And when you use what depends on what you have in the string. So, for example, if you use a single quote in the string, you can use double quotes surrounding the string. Then you don't have to do something special when you have the single quote inside here. If you have a double quote inside the string, you use a single quote outside the string. You can also use special control characters in the strings. So, for example, so all the control characters have a backslash in front of them. So if you want to use a backslash, you have to use the control character //. Then you have a backslash in the string. If you have a single quoted string and you want to have a single quote inside that string, you can prefix it with a backslash, and then you get a single quoted string, a single quoted character. Same thing if you have a double quoted string and you want to have a double quote inside a string, you can have prefix it with backslash, and then it will insert that in the string. \n will give you a new line. \t will give you a tab character. So in this case here, I have a string here, Guido van Rossum, and then have a \n here. That means this is a new line, and then the new line here prints out Python creator. So if I run this, it will print on 2 lines here like this. So \n will add a new line and go to the next line. In some cases, you don't want Python to do any interpretation of the string. So basically, you don't want it to interpret any control characters. I want really to have the \n as a character in the string, or characters in the string. Then you can prefix the string with an R, and that means that the string becomes something called a raw string, and it tells Python not do anything interpretation of this string, just leave it as it is. And I just illustrated here with 2 variables here, raw string and standard string, and I will just print them out and see if they are different. So if you see in the first example here, it will print out the \n in this case, because now it doesn't do any interpretation of the string. In the second example, it will actually print our 2 lines, because now it interprets the \n as a control character and goes to the next line. Then there is another really good string type, and it's I call them triple quoted strings. Those starts with 3 quotes, either double quote or single quote, that doesn't matter, but 3 quote characters. And then you can enter the string with character line numbers just that you see on the screen. In this case here, I line break here, I have another line here, and a second line, third line here, and I end with a quick triple quoted string. And Python will interpret this line breaks and formatting just like it appears in your source code. So this is an excellent way of, if you have templates for files or templates for an HTML code or anything, you can put them in triple quoted string. They will appear exactly like you write them in your source code. So if I run this here, you see here that this string will print it out just like it's formatted here. You can also use them as for documentation. So if you put them in your source code with triple quoted strings, they will be ignored by the interpreter. It will store it as a documentation. Either if you put them directly on the function, there is a documentation for the function. If you put them inside your middle in your source code, it's just documentation in the middle of your source code. Lengths of strings, then you use the length function again. So you see here that certain functions are useful for multiple object types. So in this case, I have 2 strings, and I can query them using the len s1, len s2, and I get the number of characters in that string, those strings. This limitation of immutable strings, you can see here that it's very easy to create new strings. combining existing strings. So in this case, I have S1 and S2. Those are strings, and I combine them together, and then print out S3 here. So you see, it's very easy to create a new string. You can also repeat strings. So the multiplication operator in Python can, if you're not using floating point, it is used as a repeat operator. So in this case here, I have a string here, and I want to create a output that has an underline that is the same number of underlines as the string itself. Then I can create S2 here is a dash character times the number of characters in S1. So now you see you get this nice output here. So it has a string here, and it has the underline here that is exactly the same length as the string. Another cool function is the ability to split strings. Then you have a split method on your string. So in this case here, I have a string here, and I want to divide it up into words. So I want to do just word list equals to s.split. Then I I get a list of the words in the string. It looks something like this. You see here that it's now I have a list of strings instead. Split can also, by default, it uses spaces to divide strings, but you can also specify the separator to what to split the string. So what to use as the splitting point of the string. So in this case here, I have a string consisting of numbers that are separated by commas, and this is a very common thing in numerical codes or finite element codes that reads input, that you have data stored in text files with comma separation, and you want to split them out. Then you can add a parameter here to your split command, comma, and then it will split on the comma characters instead. So now you see here you have 1, 2, 3, 4, 5, 6. The only thing you have to notice is that if you get the space will also be part of this split. So you have to do another parse where you clean that up. But this is interesting. So split is a very powerful function. I will guarantee you will use it sometimes down the line if you're continuing with Python. So suppose you have a list of strings. How can you convert those into strings? So then there is a join method, and the syntax of this method is a bit, not a bit, it's very odd. So what you do is that this join method operates on the character you want to join the items in the list of. So in this case here, I have a list of strings, and here I have a space here, and I want to join that space together with the list. So in this case, it will append and create a string with spaces between the words. You can have a comma here, and then it will create a string that has the words separated with comma characters. And then you can, if you have an empty string, it will kind of join them together without any spacing. So let's see the differences here. So in the first one, it adds the words together with space. The next one, it uses the comma characters. And the final one, it just puts everything together in a single string. Searching strings. So what you can do, there is an operator called in Python, which you can check if something is in a string. And so, for example, here I want to check if the vocalia word is in the string. Then I just say vocalia in S, that will return true if it's in the string. So it says true. If I search for vocalia instead, it should return. No, I'll search for my name instead. Jonas in. No, it's not part of my string. So this is a way to quickly search, and you can use that in if statements later, which I show later on here. You can also use the find method to kind of find the index of the first occurrence of this this pattern you're searching for. So in this case here, find far. and it should return 0, 1, 2, 3, 4. And then you can, as a second parameter, you can specify where we should start searching from. So here I continue searching for position +1. And let's see what happens here. So the first one is position 4, I searched correct. Next position is 41, could be here. And then it searches for Python, which it doesn't define, and then it returns -1. So if it doesn't find anything, it returns -1. As I said before, sometimes you have strings that you need to clean up in some way. For example, if you have trailing or leading spaces here, so in this case here I have several characters here which I don't want, then I can do the strict method here. It will remove those characters and return a string without those. So you see here that the strict version here just contains the string, doesn't contain this leading space. There is also a corresponding version of this called rstrip, which is does the same thing, but from the other side, so on the right side. So I have extra spacing here. It removes that on the right side. And then I have the same one, but left side. So I can do left side. So the strip version removes spacing from both sides. Right strip from the right side, left strip from the left strip, the left side. There is also a way of querying the data type. So if you're uncertain of a data type or what data type a variable is, there is a function called type which you can query to see the data type. So in this case, I have created 4 variables here, and I want to check the data types of each of them. And you can see here that int, float, bool, string. So it's not like an untyped language where you're converting pointer data types or something from a pointer to a data type. This is every variable has a data type. It's not a typeless language. It's a dynamically typed language. So here you can see that actually int is the integer, float is a floating point, bool is boolean, and so on. Let's see how much I will get through this here. I think I will manage it. So the final data type that is also one of the more important ones in Python, and also a really efficient data type if you know how to use it, is the dictionary. So compared to lists, so a dictionary stores data in key value pairs. You have a key which you can use for lookup, and that key is associated with a value. It's almost as easy to create a dictionary as a list, but instead of square brackets, you use curly brackets. So in this case, to create an empty dictionary, you do values equals to curly brackets. You can create a pre-filled dictionary, and then you have to specify the key and the value. So in this case here, I have a Petra here is the key, and the value is connected here to Petra is separated with a colon here. That can be a string, a floating point, an integer. And then you have David here, and his value is this one. But this is like a phone book. Ulla, and then you have a key there, a value to that key. So if I print this, run this, you see here, this is the way it prints out the dictionary. Key, value, key, value, key, value. So each key value pair is separated with a comma. So you can access the values in the dictionary using the same kind of way you do with lists. So you specify with square brackets, you specify the key. In a list, the key is the index of the position in the list. In a dictionary, the key is the key data type you access here. So in this case, we have used string keys, but then you access the key as a string here. You run here, you can see it returns the values of these keys. The same thing as with list, you can assign values here. So in this case here, I have values Peter equals to 7, 3, 4, 8, 7, 4, 7. That means that if Peter doesn't exist, it creates a new key value pair and assigns the key Peter this value. The powerful thing with a dictionary is that you can actually really quickly search for items in a dictionary. You could have solved this thing with two lists, for example. You can have a list of the names, a list of the numbers here. But then you have to, when you want to search, you have to go from the start to the beginning and find the values. That is a linear search, that's an order n time. If you use a dictionary, you can use the in operator here to query if a key exists, and that is much faster than linear searching. So it's so if you have a large data structure, this is really retrieves the values really fast. The number of values in the dictionary is the same way as for a list. You use the len item here, and it returns you the number of values, a number of items in the dictionary. Adding values, as showed before, you just create another key here. Values Guido equals to a new key. You add to the, so that automatically added to the dictionary. As with list, you can have nested dictionaries, which gives you even more possibilities to create really sophisticated data structures. So you can have dictionaries with values that are lists. You can have dictionary that has values that are other dictionaries. So in this case here, I create this is a configuration file for a program, perhaps. It has three main keys: general, constants, and items. And every of those keys are actually dictionaries themselves, using the set of keys username and temp path, and so on. And then you can access this configuration by specifying config general username. So this will go to general and retrieve the value Ole here. Constants will go to constants and find the key pi and return that one. So this is a very nice and effective data structure. And when you program in Python, look into the runtime library and see if there are data type and data structures that you can use. Because these are, even if Python is not a compiled language, it's interpreted line by line, many of these algorithms are implemented in C, very efficient C code. So if you can create a data structure in Python, you can probably do really efficient searching of these data structures and avoid implementing your own dictionary data types yourself. Use the existing ones. I don't think we have too much time left, but you can, when you go home now, I created some tasks here, which you can try out yourself in this notebook, just to kind of see if you remember something from this lecture.